Hi guys. If you don't recognize my voice, it's because you maybe don't know me. My name is Miss Nieder, and if you're listening to this, I am just one of the other Algebra 1 teachers. So you might be Miss Gonzalez's or Mr. Armour's student, but we all work together, so I am making this video that you're watching today. So we are going to start the section on 2.6 and 2.7 in your book on rates, ratios, and conversions and solving proportions. So I'm going to be leading you through that today. You should have this packet in front of you that you picked up and have your pencil ready, and we're going to work through this together, and then some of it you'll do on your own. All right? So the objectives we're going to cover this time: I can convert units and rates, and I can apply and solve proportions. That's what we'll be doing today. All right, you know these problems are always review, a little warm-up. I want you to hit pause right now, and I mean it, really do it. Hit pause and see which of these problems you can do, and once you've tried them all, then hit play again and you can check your answer. Okay? Hit pause now. Okay, check your answers to these now. All right, hopefully you were able to try them all, but we realized this last section on solving literal equations was really tough. So I'm just going to kind of talk through them a little bit, and you can see maybe where you broke down if you didn't quite get all the answers. So remember on this one, the tricky part is x is showing up in two separate places, right? But those are not like terms, really. We can't really just combine them together. So what we do is we factor out that x. Remember, we're going backwards from the distributive property. So if we factor out that x, we have an a minus 1. Did you get that that was 1? Left in the parentheses, right? So then you just divide both sides by a minus 1. And when they cancel over here, you get your answer, x equals c over a minus 1. Okay? Number 2 maybe wasn't quite as hard. To get the x by itself, the first thing you need to do is multiply by b on both sides, right? Because the top, remember, when it's all in the numerator, it's kind of like there's an understood parentheses around that numerator. So we get rid of the division first by multiplying by b on both sides, and that gives us this part. Then we want to get x by itself here, so we add v to both sides, and those aren't like terms over here on the left, so we can't combine them, so we get by plus b equals x. All right, and then number 3. This one's probably the easiest one of them all. Hopefully everybody got number 3. We want to solve for this x right here, so the first thing we do is we added t to both sides, and then that gave you 6x equals y plus t. Then to get x by itself, you divided 6 on both sides, and then that gives you x equals y plus t divided by 6. Okay, and then the last one, number 4, is very similar to number 1. So you'd use the same steps. We have the x in two places. Because the r and the s are not the same variable, we can't combine them, so we factor that x out in front. That leaves r plus s left in parentheses. Again, if you redistributed that, you'd end up with what you started with, so you know it's equal. Then I can divide both sides by r plus s and get x equals 1 over r plus s. Okay? If you're still struggling with those, just come in and see your teacher before school, and we can work more on those with you. Okay? Flip the page and go to your notes-taking page, all right? And let's write down our objective again. Our objective here that we're going to learn today is that I can convert units and rates. Okay, that's our goal. I can convert units and rates. And if I go too fast here, remember the speed is under your control. If you need more time to write, just hit the pause button while you're writing, and then just hit play again when you're ready to go. So what is a rate? A rate is a ratio, okay, not a ration, a ratio that compares quantities in different units. And a ratio is basically just a fraction. Don't let that word bother you. You know what a fraction is. A ratio or a fraction that compares quantities in different units. Okay? So, you know, things like miles per hour. If you drive 50 miles per hour, that's a ratio, basically, of how many miles you can drive in 1 hour. Gallons per minute. When you take a shower, how many gallons of water per minute do you use? That's a ratio or a rate. Okay? And then what we're going to be doing is converting them to different units. So some common rates or ratios that you know. We know that there is 12 inches in 1 foot. Okay? This is a special type of ratio that we call a conversion factor. So it's a ratio of two equivalent measures that are in different units. Hopefully you all believe that 12 inches is equivalent to 1 foot. So when we put them together in a ratio form, we get what we call a conversion factor. And we call it that because it is going to help us to convert from one unit to another. Okay? Some other ones that you may know. How about 1 meter? How many centimeters are in 1 meter? Well, there's 100. So this would be a conversion factor. We know there's 1 meter and 100 centimeters. Those are the same quantities. So when we put them together in ratio form, it's a conversion factor. Some other examples, there are 16 ounces in 1 pound. Okay? And another one, there's 4 quarts in 1 gallon. And there's all kinds, there's many, many, many more conversion factors that we could use, but this is just a small sample of a few. Okay? We'll come up with some more later as we do more examples. All right, so let's do just some converting between units and unit systems. All right? I'm going to skip number 1 because I think that's kind of the hardest one. We'll come back to that at the very end. Let's do number 2 first. If we have 25 miles an hour, and it says we want to change that to miles in minutes, so basically changing miles per hour to miles per minute. Well, we're going to go ahead and write that as a ratio. So I'm going to write 25 miles, and I'm going to abbreviate that. And that's per hour, so that's really in 1 hour. You don't have to write the 1, but you can if you like to kind of hold that place with a number. And we're trying to convert that to miles per minute. So the miles here isn't going to be changing, but we want to change hours to minutes. So we need the conversion factor for that. So ask yourself, what's the connection between hours and minutes? What's the conversion factor where the two parts, the top and the bottom, are equivalent using minutes and hours? And hopefully you said, well, I know that in 1 hour there are 60 minutes, right? You all know that. 1 hour there are 60 minutes. All right, so then notice what we have here. I put a multiplication sign in there. We're going to multiply always by the conversion factor to change our units. And now look what we have. And this is the same as when we multiplied fractions before to solve equations. If we have hours on top and hours on bottom, they cancel each other out. It's like hours over hour. It's gone. Okay? So now what do we have left? We have 25 times 1 on top, and the units on that is miles. 25 times 1 is just 25, so I still have miles on top. And on the bottom, I've got 1 times 60, which is just 60, and my units that I have left, because hours has been crossed out, I have minutes. So 25 miles in 60 minutes. Well, we don't usually leave it like that. We go ahead and compute 25 divided by 60, and that comes out to be about 0.42. And so we keep the same units, and we have 0.42 miles per minute. Okay, so a little less than half a mile. So if you're going 25 miles per hour in your car, you're traveling a little less than half a mile in 1 minute. Okay, so that's how we change units. Some people kind of call this the railroad because it's almost like you're setting up railroad tracks here. You may have heard that maybe in science class. But I just call it setting up the conversion factor and then canceling units that occur on top and bottom. All right, let's go to number 3. We want to convert 3.5 days to minutes. So this isn't a rate. This is just changing the units. Some of you might be able to just do a simple calculation in your calculator and get it. But if you don't, if that doesn't seem logical to you, you can set it up. I have 3.5 days, and I think, okay, what's my conversion factor that I'm going to multiply by? I want to get rid of days and change them to minutes. So we have to think, well, how many minutes are in a day? Okay? Well, I don't really know how many minutes are in a day. But I do know how many hours are in a day, right? So sometimes we might have to do a couple conversion factors. I know in 1 day there are 24 hours. Well, which one do I put on top and which one do I put on bottom? Well, I want days to cancel out, so I'm going to put that on the bottom so it cancels. So in 1 day, there are 24 hours. Okay? So days will cancel. So now my units are in hours, but I want minutes. Okay? So I have to think, how do I cancel hours out? What's the connection between hours and minutes? Oh, I know. In 1 hour, there's 60 minutes. Well, which way do I put it? Which goes on top? Well, I want hours to cancel, so this hours has to be on the bottom. So in 1 hour, I know there are 60 minutes. So now my hours cancel, and my units are minutes, which is what I was going for right here. Okay? So looking at what I have, on the top, I got to multiply across when I multiply fractions. I've got 3.5 times 24 times 60. On the bottom, all I have is 1 times 1, so I really don't need to write that, right? Divided by 1. And my units on this are minutes. So compute that out on your calculator. See what you get. And you should get about 5,000, or exactly actually, and 40 minutes. Okay, so that's how many minutes are in 3.5 days. Okay, get that down or hit pause because I'm going to erase that so I have room to do number 4. All right. Okay, number 4, 14 gallons per second. So that is now a rate. So 14 gallons per second. We're going to write that like that. And we want to convert that to quarts per minute. So now not only are we changing one of our units, we're changing both. Gallons has to go to quarts and seconds has to go to minutes. It does not make any difference which one you change first. You'll get the same answer. So let's do the time first. I'm going to change seconds to minutes. So think to yourself, what's the conversion for seconds to minutes? What's the relationship? Well, I know there's 60 seconds in 1 minute, right? Well, where do I put the 60 seconds, on top or bottom? Well, I want seconds to cancel, so that means it needs to be on top. So there are 60 seconds in 1 minute. Seconds cancel. So now I'm in minutes. I'm in gallons per minute, to be exact. But I don't want gallons, I want quarts. So look up top, what do we say is the relationship between gallons and quarts? Well, we said there were 4 quarts in a gallon. I want gallons to cancel. In order for it to cancel, it has to be on the bottom. So I know in 1 gallon, there are 4 quarts. And so my gallon units will cancel. And now notice my units left are quarts per minute, which is what I want. So what's left? On top, I have 14 times 60 times 4 quarts. On the bottom, all I have is 1 times 1, so I really don't have to write that. But I do have the units of minutes, so that goes down here. And so when I multiply that all out, 14 times 60 times 4, you should get 3,360, and the units on that are quarts per minute. Okay? So get that written down. And then we're going to go back to number 1. Number 1 is 100 yards, and we just want to convert that to meters. So again, this is not a rate. Okay, it's not a ratio. We're just changing our units. So we start out with 100 yards, which we know is standard English unit measurement, right? And meters, which is metric. Ooh, I don't really know how many yards are in a meter. Do you? You can Google it. If you have your iPad or your phone handy, you could certainly Google that. But I'm going to use what I know. I was taught back in science that there are 2.54 centimeters in an inch. Okay? So we could use that, but that means we've got a bunch of stepping stones to get from yards to inches and then to centimeters and to meters. Okay? But certainly you could Google and see how many yards are in a meter and see if that would come up. There's a lot of little websites that do conversions for you. Okay? But I'm going to use this one here that I'm giving you. So like, okay, I've got to get yards to meters. Well, this conversion here is in inches and centimeters. So how do I get from yards to inches? Feet. Do you know how many feet are in a yard? Hopefully no. There are 3 feet in 1 yard. Okay, I'm going to erase this so I have more room. All right, so that cancels out my yards. Now I'm in feet. All right, but I need to get into meters. But oh my gosh, I got to go to inches first. I know in 1 foot there are 12 inches. So those will cancel. So now I'm in inches. All right, well here my conversion says there are in 1 inch there are 2.54 centimeters. Getting closer, ooh, now I know there are 100 centimeters in 1 meter, right? So inches here cancel, centimeters here cancels. My units that I'm left with now are meters. So to get to meters, what do I have on top? I have 100 times 3 times 12 times 2.54 times 1 meters. And on the bottom, look, all I have is 1s times 1 times 1. Oh, times 100. So I've got 1 times 1 times 1 times 100. Okay, there's no units left down there. When you put that all in your calculator on top and then divide by 100, you should get 90 meters. Now, if you Googled it, you maybe could have done that in one step. If you knew how many yards were in a meter, you certainly could have done that. But that would be the way of doing it if you just had to use some ratio that you had memorized in your head, or that was maybe in your planner. Sometimes they used to have conversions in the planners. Okay, so let's look at this last example then. Which weighs more, 500 pounds or 200 kilograms? Okay, now I didn't know this one. I didn't remember this one from science class, so I actually did Google it, and I found out that in 1 kilogram, that's about 2.2 pounds. That would be helpful to know, because back when I was lifting weights and the weights were kilograms, I never really knew how many pounds I was lifting. So I don't know why I didn't look that up a long time ago, but now I know. All right, so we want to know what's bigger, 500 pounds or 200 kilograms? Well, let's convert pounds to kilograms so we can compare more easily. So 500 pounds, okay, and I'm going to convert because I know that there are 2.2 pounds in 1 kilogram. Now, why did I choose to put the 2.2 pounds on bottom? Because I want the pounds to cancel, okay? So now what do I have left? I just have 500 times 1 on top, which is just 500, and I've got 2.2 on bottom, and then my units left are kilograms, which are on top. So if I divide 500 by 2.2, I get 227.3 kilograms approximately. So which is bigger, 500 pounds? That's the same as 227.3 kilograms, which is certainly bigger than 200. So 500 pounds is a little bit heavier. Okay? All right, so this is the end of this video. I want you to go ahead and try your practice problems. They're on the opposite page, starting with the one about prices for a shirt. Go through and work as many of those as you can, okay? And then you're going to open the next video and you can check your work. All right? Go ahead and start.